Today we're going to be taking notes on section 4.4, which just goes over all of Earth's history, so Earth's geologic time scale. So, as we have learned about Earth's history, we have learned that some changes on Earth have been very, very sudden, and some changes on Earth have been very, very gradual. The principle that talks about how a lot of the changes on Earth are very sudden is called catastrophism. This means that some landforms are created through big catastrophic events like earthquakes, breaking down mountainsides, and volcanoes building up islands, things like that. Asteroids having a really major impact on Earth. All of those things are catastrophic, sudden events. Uniformitarianism is kind of the opposite of that. Uniformitarianism is that principle that just says, no, some of the processes that have shaped Earth's features are very gradual and slow. Things like erosion and deposition, they happen over a very, very, very long period of time. And those changes are just constantly at work, constantly shaping Earth. On this slide here, we have the top picture, which is just an example of a catastrophic event. And then on the bottom here, we have an example of how erosion, which is a uniformitarianism example, how erosion can shape a canyon over millions of years. We know that Earth is actually shaped through a combination of both. Some of our landforms are built up and broken down through very sudden catastrophic events, and some of our landforms are built up and broken down over very slow, gradual events through uniformitarianism. As we talk about Earth's history, we are going to use what we call the geologic time scale. The geologic time scale is kind of like Earth's calendar, but the difference is that our calendar of Earth is not broken up into even years, months, weeks, days. The calendar of Earth's history is more broken up by major changes that have happened on Earth. What we might call an eon or an era or a period or an epoch, which are the divisions of geologic time, they're not going to each be evenly divided. It's not going to be like a century and a decade and a year and a month. It's not going to be evenly divided. It's mostly going to be marked by major changes between what's living here and what our environment is like overall throughout Earth's history. Eons are the longest division of Earth's history. There have been 4 eons in the past. And then each eon is broken up into eras, and each era is broken up into periods, and each period is broken up into epochs. That word epoch is pronounced epoch. It is important to remember, like I just said, that it's not an even division. It's divided by major changes and major events in Earth's history. Oftentimes, those major events are mass extinctions. Mass extinctions happen when lots of things die at one time, usually because of a major environmental change on Earth. It could be like an asteroid hitting Earth, which is what we infer may have caused the demise of the dinosaurs, or it could be warming of temperatures, lowering of sea levels, anything like that. It could be something very sudden, or it could be something gradual, but marked enough that it really, really affects the landforms and the life forms that live here on Earth. This is a video that puts the history of Earth into a little bit more of an understandable perspective here. Okay, so you can see over Earth's very, very, very long history, we as humans didn't come into the picture until very, very, very late in the game. So Earth has been around for a very long time, and we have only been around for a tiny, tiny fraction of it. So when we talk about Earth's super long history, again, it's easiest to talk about it in terms of geologic time. The current eon that we're in is called the Phanerozoic eon. The very first era of our eon is called the Cambrian. So anything that happened before our current eon is called pre-Cambrian. Pre means before, right? So anything that happened before our current eon, which has still been a very long time, is what we call Precambrian. We don't have a lot of Precambrian fossils out there, and that's because life hadn't yet really figured out how to make those bones and exoskeletons and shells that we need to become a good fossil. During Precambrian time, this is where the Earth very first started forming. At first, our whole Earth was just molten rocks. The continents started forming, pulling apart, crashing together. Supercontinents formed and then separated and then formed again in different shapes. Our atmosphere very first started forming because of these teeny tiny little cyanobacteria, which existed in our oceans. And these very first, the very first atmosphere was created by volcanoes, and then cyanobacteria took that sulfur that was created by those volcanoes and basically ate it for food and breathed out oxygen. So it's because of those teeny tiny little cyanobacteria that we have an atmosphere that we can breathe today. So after the Precambrian time, we entered into our current eon. This is where we're going to spend the majority of our section here. So our current eon has been split into 3 different eras: Paleozoic, Mesozoic, and Cenozoic. Paleozoic is the oldest of the eras in our current eon. And paleo means ancient, and zoic means life. So this is typically where when we study Paleozoic life, we're talking about ocean life, usually. So during this time period, Pangea formed, sea levels started to drop, climate varied across the planet, but a lot of our oceans were pretty shallow, so a lot of the ocean water was pretty warm because it was warmed up by the sun. So a lot of life was able to flourish. This is what we call the Cambrian explosion. This was where life really, really did well because the oceans were a good environment for all kinds of life to really start experimenting with evolution and figuring out what could survive here and what couldn't. So we started to see a really big diversity in species in our shallow oceans in the Paleozoic era. At the end of the Paleozoic era, we had a mass extinction, which was at the end of the Permian period. This is what we call the Permian extinction. This is where 90% of our ocean species died. So the remaining 10% then lived on to our next era and became dinosaurs. So Mesozoic era is our middle era. Meso means middle. This is where we started to see really a lot of reptiles. So eventually Pangea broke up around 200 million years ago. The oceans and sea levels started to get a little bit deeper, and the climate started warming up. The reason the climate started warming up is because there were lots and lots of volcanic eruptions. As our plates were really moving around and shifting, we had lots and lots of volcanic activity, which added a bunch of greenhouse gases, carbon dioxide, into our atmosphere. So that really warmed up our climate. This made for a really good environment for reptiles to live, because we know reptiles are cold-blooded, including the dinosaurs. There were some small mammals kind of running around here, and this is what would eventually evolve into all the mammals that we have here today. But most of the mammals that lived were small, like rodent-sized animals that were kind of living among the dinosaurs. They were not the major species or the major type of species on the planet. We had a mass extinction at the end of the Mesozoic era. This is the one that I'm sure most of you are familiar with. We had an asteroid that hit Earth off the coast of Mexico. This caused a huge chain reaction in all kinds of different events. Lots and lots of blocked sunlight because of all the debris and fireballs that were falling from the sky. Lots of things ended up going extinct because of the blocked sunlight, killing the plants, which then did not provide food for those herbivores, which then did not provide food for the carnivores that were trying to eat the herbivores. So lots and lots of species went extinct around 65 million years ago because of this one major asteroid that collided with Earth. Then we moved into our current era, which is our Cenozoic era. Ceno means recent, or Ceno, recent, so recent life. This is what we call the age of mammals. This is where Pangea really finally, like the final bits of Pangea have broken up. Our plates are still moving today, but generally the continents got to where they are now. Climate started to cool. We went in and out of a few different ice ages. So our poles got cold and then a little bit warmer and then cold again and then a little bit warmer. And this is where mammals really, really flourished. With those big giant dinosaurs gone that were eating those rodent mammals, now these mammals can do really, really well in our colder climates, especially because they are covered in hair and fur. So these mammals really do well, and then we end up seeing the evolution of all of the different species of mammals that we have here today. Okay, so that is the end of the 4.4 notes. Let me know if you have any questions.